The broadcast is now starting. All attendees are in listen-only mode.
Hello, and welcome to Think Big's When Hadoop Isn't Enough webinar. Today, we have with us Aravind Srinivasan. He's a principal consultant at Think Big. Aravind's worked on many projects relating to all different industries. This one is particularly geared towards media and social media. And today he's going to be walking through a real life use case that he worked on very recently. With that, I'll hand it over to Aravind. And if you have questions, please go ahead and feel free to type them in and we'll answer them as we can. Aravind, go ahead.
Thanks, Anna. Welcome, everybody. Hope you guys can hear me and see my screen. Basically, today we are going to talk about an interesting enterprise data warehouse project, which me and my team was involved in with a social media company that Anna was talking about. And this is interesting because of in a couple of different reasons. One was this is one of the largest data sets that we dealt with. And the second reason this was interesting was the mix of technologies that had to be used to handle the scale and the complexity of this environment. This is why this webinar is titled When Hadoop Isn't Enough, because this environment kind of stretches Hadoop to its limits, and we had to go in and look at various ways to make life better, which in some cases took us in interesting directions, almost back to some old established technologies in some sense. But the mix and the learnings and the challenges involved were really interesting, so we thought we'd make a case study out of it. So the way I've structured this presentation, we would quickly go through the environment and what we did at this client. And then the later part of the talk, I would also up-level it and kind of look at a macro level in terms of what kind of challenges you would face in general and what kind of technology choices you should make and you should drive towards as you're trying to solve these challenges. So let's dive in. So here's an overview of the project itself. So like I said, it was an enterprise data warehouse project at one of the major media companies. We were specifically working with their business intelligence and analytics team in the IT department. They also have a huge engineering team, which kind of is responsible for the infrastructure pieces and the Hadoop clusters and things like that. And the interesting use cases are from the IT teams, which uses that data and the warehouse for their business intelligence and reporting and other analytic purposes. And this environment is almost exclusively Hadoop when we got there. It's a very startup-driven culture, even though they're pretty big right now, and they had always hitched themselves behind the Hadoop wagon. And it's also exclusively almost Hive. And it's a very open environment where they have opened up their data and analytics platform to the entire enterprise. And essentially, anybody can go in and write any kind of query, mostly in Hive, and kind of get their work done. Now, obviously, that worked well when they were smaller. Now they are at a size and scale where they're starting to see some challenges. So one of the challenges that at a very high level they're facing is Hive is a great analytics platform, but they're operating in an environment where it's almost exclusively the only platform of choice for all of their users. So the goal was to explore some other solutions so that some of the high value use cases could operate better. So when I say better, what do I mean? What are the challenges they are facing today? Let's look at the problem. So the problem basically is they have grown to, literally 100 petabytes plus. It is one of the world's largest Hadoop warehouse. And like I said, it's a very open environment, and they're actually handling thousands of Hive queries every day. And this is not in just one cluster of 100 machine or anything like that. They are not resource starved at all. They have thousands of nodes running Hadoop and Hive, and it's spread across multiple clusters and multiple data centers and all that good stuff. But still, the scale has gotten so large that there's a lot of reliability issues and unpredictability around SLAs and things of that nature. Also, if you have an open environment like that, you also run the risk of users doing a lot of things that's not ideal for the collective. That's where I have a bullet point about multiple copies of data. So everybody makes yet another copy of the same data just because they needed it, partitioned slightly differently, or bucketized slightly differently, or in some cases they just do not know that a data set even exists because there's another team from another part of the company which operates that. And these data sets are huge. So these are some of the problems they are dealing with today. Aside from the fact that Hive itself is not efficient for all kinds of queries. For instance, it's not optimized for all kinds of joins, and the data in Hadoop and Hive is typically denormalized and things like that. And you could say a lot of these problems that I'm talking about are symptomatic of any enterprise data warehouse that is kind of open and available to everybody. But then I think Hadoop also adds on to that in the sense that there is a psychological effect there, that this whole notion that Hadoop runs on commodity hardware and it's cheap, I think lets these environments grow even more in an uncontrolled fashion, because it's not like expensive Oracle or any other commercial solution. People think, oh, it's cheap, storage is cheap, let me make another copy, or let me pound it with another long-running query. And of course, in this particular enterprise, like I said, it's a very open, encouraging environment. So there was also some cultural issues wherein there's really no control. So their existing environment, in short, really was growing out of control and causing all kinds of problems. I like how they themselves characterize this internally. Essentially, any solution, I guess, to a problem starts with awareness and not being in denial. So they are very aware of the challenges that they have created for themselves in this environment. I'll give you a few seconds to go through this slide, because it's an interesting economic concept in economics called tragedy of the commons. They kind of look at their data processing environment to suffer from this. I'll give you a couple of seconds to read this. So yeah, so essentially what they're saying is they have this environment running Hadoop, Hive, large, it can handle a lot of traffic, a lot of data, and the teams are just going out and doing whatever that's best in their own self-interest. I mean, these are smart engineers who are doing great work for their teams, but they are continuously depleting a common resource which is not in the best interest of the enterprise itself. So this is how they've characterized the problem, and they've started looking at solutions to manage this whole environment better. So what did we do? So one of the solutions that we are exploring, or we are starting to implement, is this whole notion of a pyramid, wherein, okay, HDFS and Hadoop is great. It handles a lot of data, big data, and they have shown they can grow it up to 100 petabytes or larger. But obviously, it's not going to solve all of world's problem and cure AIDS and solve world hunger and stuff. So we are starting to look at segmenting use cases and moving them to appropriate technology. So as you look at this pyramid, obviously any in-memory solution at the top is going to give you the best performance, but it's also going to be really expensive. Then as you go down the stack, you got HDFS has all of this data, but then tools like Hive are not going to be the most responsive, most real-time type access to this data. So this whole project was to build kind of like an enterprise data warehouse layer. You can almost look at it as a high performance cache. The idea is no way you want to put the 100 petabytes in either a commercial MPP database or in memory. I mean, that's really expensive. So we started looking at enhancing this analytic environment with the enterprise data warehouse using some traditional MPP architectures and databases, and move, let's say, 100 petabytes out of the 10 petabytes out of the 100 into this environment, and just move certain high value revenue analytics to it, things that deal with money and ad revenue and whatnot. The idea being just to drive better analytics, query response time, and maybe some use cases need better data modeling and dimensional modeling that Hadoop is not known for. So we were brought in specifically to look at this and work on that EDW piece, which some may argue the world typically is now moving from the MPP technologies to Hadoop, but this environment was so heavily Hadoop and was getting so out of control, we had to kind of slide in the traditional MPP technology and see where it fits, how it fits, and how we can enhance this environment. So what was ThinkBig's role in it? Like I said, we are basically have traditionally been the big data expert, especially with Hadoop. So we were brought in to bridge between Hadoop world and the new EDW. Today in their environment, most of the data either sits in Hadoop or ends up in Hadoop. So we obviously need to move some of this data to EDW from Hadoop or from their raw sources. And they have multiple high traffic sources. There's a lot of complicated data flows and hundreds of pipelines doing these processing to deliver the data these analysts need. So the challenge was to design and deliver a data integration and ingestion into this EDW from their existing environment. So this involves a lot of things, right? I mean, you have to pick the appropriate design for the data flows, because some of them belong in Hadoop, some of them need to move to this new environment. There's also some questions around, how many times can you copy the data? Some of these data sets are huge. Hadoop environment is never going away. It is the source of record for them. So do you want to move data from Hadoop to this MPP, or do you want to directly ingest from the sources? How would you handle that? What's the network impact of such a design? So there are a lot of details around that. And they had some MPP experts, and we kind of were the Hadoop experts, and we kind of cross-trained each other and learned from each other. And the team worked on building this architecture. This is probably a good time for a poll. Anna?
If you guys will just take 30 seconds to fill this out, it would be helpful. Okay, thank you. The answer actually, so Aravind, 45% of the folks on the line are using Hadoop. Go ahead.
Okay, cool. Let me continue. So now let's kind of get into a little bit more details about their environment, a little bit more technical details. That was more of an overview of the challenges. So their environment specifically uses Scribe for all of their log traffic, and this is huge traffic, multiple gigabytes per second. And like I said, we were just looking at a subset of data for the enterprise data warehouse, which we were trying to build. And even that data of interest was almost 5 gigabytes per second. And they use MySQL for all of their dimensional data. And that's what is driving their operational side. Obviously, Hadoop on the warehouse is at the back end for analytics. Their operational environment is all MySQL. And that's handling tens of terabytes and millions of updates a second. This is not, your typical MySQL. It's been sharded heavily, and they have almost 200,000 shards across the world serving their operational side. Like I said, and all of.
I think you need
Sorry?
to advance your slide.
I did. Which slide are you seeing?
We are seeing the poll slide.
Nope. I'm on the slide which says the environment. And by the way, I never saw the poll. Maybe you have to switch from your screen to mine or something.
All right, go ahead. Keep going.
Okay. Yeah, stop me again if you don't see the screen. So the backend analytics is all Hadoop, mostly Hive, but they built, they have a very strong engineering team, which has built many custom tools, enhancement to Hive, cool Hive metadata uh, system, as well as they have built a complex namespace management, because as you can imagine, with so many clusters and so many data centers and so many data sets being copied around and moved around, they have a really cool namespace management infrastructure that drives all of this. They also contribute back to the open source. So some of the tools are open source, but some of them are internal to them. So at eye level, this was the architecture. Basically, if you see today, all of the traffic data from Scribe, all of the data, dimensional data from MySQL, they all end up in the HDFS clusters. So HDFS is still the source of record because that's where most of the enterprise's work happen. Now, the MySQL tables are often collected at the end of the day, once a day, and daily ingested into the HDFS clusters for analysts to run their analytics on, on a daily basis. Obviously,
Aravind,
the load on, yeah?
people can't see your screen. Can you?
Sure. Let me see. Can you, I clicked on show my screen. Stop showing my screen. Now I say show my screen. Did that help?
There you go.
Okay. Cool. Thanks. So the data is pulled from the MySQL, the dimensional data once a day and ingested into the HDFS clusters today without really being careful not to affect their operational side. Now, when we bring in an enterprise data warehouse in this environment, so we had to first design how to get the traffic data we need into this this new EDW, how to get the dimensional data from MySQL, as well as what kind of process tables would we just take it from HDFS to do our analytics, because some of that belongs in HDFS, and it may be too hard to recreate in this new environment. So it was a process of going through and understanding the business use cases and the value of almost each data set and the value of recreating it in this EDW versus pulling it directly from Hive, and also figuring out what's the most efficient way for these data sets to end up in this EDW without, totally destroying their network capacity and operational systems. And they also have a PubSub system that's built so that all the MySQL updates are published and you can subscribe to them. That's pretty neat. Again, there is addition there in terms of what do you want to ingest directly through those kind of systems versus what can you wait for until the end of the day to just get it from their existing HDFS clusters. Analysts, obviously, if you saw this new EDW and say it's fast, they want everything there, and they're just assuming everything is going to be, honey and milk. But really, we don't want to end up creating a new environment which is just as bad as the old environment in terms of traffic and unpredictability and reliability. Again, the idea is not to create the tragedy of commons in this new environment. So in terms of deploying this EDW, again, there are some design decisions and challenges there, because today's HDFS environment is spread out across multiple data centers, and they have these cool namespaces which are spread across these data centers, and they have built great tools to move data amongst these clusters. Again, some of these problems may not be too relevant for small Hadoop clusters and small data sets, but somebody who's really moving from big data to what I call humongous data have to deal with similar issues. You need strong namespacing semantics. You need good replication because data is moving all over the place, and you're getting new requests all the time to take data from one data center to another and things like that. They have some of those pieces in place, especially in the Hadoop context. We had to go in and add this EDW layer, and we also have to take care of things like disaster recovery. So we came up with a design where we would have primary in one data center and secondary, and then we had to work with the Hadoop clusters and the namespace mechanism to see how efficiently we can get the data into these two environments. Also, most of these MPP databases have their own notions of replication, but they tend to be expensive sometimes in terms of network footprint. Some of the MPP that were being evaluated were Oracle, Vertica, Teradata, and technologies like that. So each one of them also had different characteristics. And obviously, they're not open source, and it's not an open environment like the Hadoop environment. So we had to bring that all together. And like this picture shows, we decided most of the data would either come from Hadoop or the Scribe data, which also ended up in Hadoop. They would be more real time. They would be ingested into the EDW on both data centers, and any process data that needs to be replicated will be replicated through the MPP replication itself. So that, in a nutshell, was what was going on in this project in terms of taking this humongous Hadoop environment and kind of segmenting it, if you will, into a MPP high-value analytic environment. So in phase one, what we did was, there was a lot of work around understanding the environment, the technology, the business, the processes, people, all of that stuff. Also, evaluate the technology options available, because as you could see, you could clearly do things multiple ways. If you want a piece of dimension data from MySQL, do you directly go to MySQL, or do you wait for it to be delivered to Hadoop and then take it from Hadoop, or what is the business value of going one route over the other? If you're going to bother the operational MySQL database, is it worth it for your use case? There's a lot of decisions to be made. Plus, this environment was, very good in terms of having a lot of engineering tools, and internally they have multiple solutions almost for every problem. So we had to pick and choose what we wanted. Also, we prototyped some of these options, both for functionality and performance. And as you can imagine, a major work in a redesign of a data warehouse is essentially data lineage and provenance and capacity. Basically, understanding the data flows, understanding the business value of those data flows, understanding the traffic characteristics, retention requirement, security requirement, all of that good stuff. So at the end of it, we basically had to come up with an architecture and design recommendation, which we did. Example piece of work would be something like this. Right? This is a very typical pipeline they have. It's probably one of the simpler ones. So as you can see, there's a whole bunch of data flows, both from the dimensional MySQL system and the traffic logs. And then there's a whole bunch of joins and unions and whatnot. And finally, it creates a table like the one shown there as the output table. So when you look at this and say, okay, the client says, okay, this table is very important. We need it on this new EDW. Hive is taking too long to process this or whatever. Then you basically start redesigning this and say, okay, how do I do it in the EDW? The easy, dumb way to say this is, okay, we will just ingest all these dimensions and facts into the EDW and recreate the entire pipeline in the new system, whether it's Vertica or Oracle or whatever. But life is not that simple sometimes. Some of these facts are very high traffic. Some of these platforms, like Vertica, are not ideal for ETL type work. They do really good with aggregations and queries and things like that, but they're not ideal to do your ETL and basic transformations and filtering and things like that. So we had to really understand a pipeline like this and decide what stays where and what goes to this new environment. So eventually we come up with a design like this. Okay, we say, okay, this part of the pipeline stays in Hadoop and the rest of it goes to EDW. And that decision is driven by, like I said, a lot of dimensions, like basically boils down to doing the right thing on the right platform. That's what I'm driving towards. We did a lot of that across many such pipelines. Now, in phase 2, we are still on this project, and what we are going to do is basically implement all of these design decisions and come up with more efficient ways of data ingestion, data integration between Hadoop and this environment, as well as take this into production. And then, of course, the new business requirements will keep coming. We need to be agile. The environment has to be able to support more and more requirements, and the business realities will change too. The rates of growth of data in this enterprise is just amazingly mind-boggling, actually. And so these data sets are going to grow, maybe double in some cases in 6 months, and we have to be prepared for all of that. In terms of assets, what did ThinkBig bring to the table? Basically, you could say it's not a typical project in some ways, because like I said, we are more used to going into a traditional place and seeing what fits in a Hadoop environment. This was a little bit flipped. They had everything on Hadoop, and then we had to see what fits in some of the older technologies and kind of segment them appropriately. Of course, we brought a lot of big data experience, Hadoop experience, and also production level experience that is invaluable. And also this environment basically pushes Hadoop to its limit and beyond. So we were perfect to sit down and brainstorm with them about what needs to be done for Hadoop in their environment, what's next, where is it headed, how can it get better, those kind of knowledge sharing. And that's where, I value a lot of our takeaways from this project as well, because this was not big data. This is humongous data. And it was a great chance for us to both contribute and learn the best practices and the design patterns and approaches at work in such an advanced Hadoop environment. So that's a quick overview of the case study itself. Now I would like to up-level it a little bit and talk in terms of how do we look at these different tools and how do we approach this problem more from a philosophical or a theoretical level. But before that, it could be time for another poll. Anna?
Thanks. How advanced is your organization in using Storm and/or R? We could take 30 seconds. Okay. Most people are still early on, Aravind.
Okay, cool. Okay, let me try and do this the right way this time. I'm going to stop. Are you able to see it now, my screen?
Yes, you're okay.
Anna?
Yes, I can see your screen.
Okay, it says challenge.
Yes.
Okay, cool, thanks. So now that we went through the case study at kind of a high level, we saw how we took a overcrowded kind of a Hadoop warehouse environment, which is kind of unique in and of itself, as because most typical enterprises are just moving into Hadoop space. We saw how an overcrowded Hadoop environment works and what are the, some of the challenges at least, and how do we segment the use cases and push them to other technologies. But what is the challenge fundamentally? So from the old days of computing to today's modern day of computing, the challenges are still the same. You got three resources: memory, storage, and network. Their costs have plummeted, but still relatively their costing is the same in terms of what the value is to the enterprise. And you have to optimize your system based on the costing of these three resources. Now, let's go back to the pyramid. We spoke about the pyramid briefly, but let's dig a little deeper. Essentially, it's not hard to imagine. The more you push into memory, the more performance you're going to get. And as you go down to a storage solution like HDFS, it's really cheap storage, but it's meant to be a batch analytics platform, and you can't just expect great response time on 100 petabytes of data. So the ideal way to look at this is just understand these different technologies and your business use case and segment them appropriately and use the right tools for the right problem. So memory is cheaper than it used to be, but still it's not very cheap. You can definitely use a lot of in-memory solution, databases and things like that. Or in this environment, they actually had not one, but two homegrown in-memory solutions. One of which was purely in-memory. The other one is kind of a streaming type solution, which kind of used Hbase as a backing store. But the point is that's not going to work for 100 petabytes of data. So they actually, the in-memory solution is ideal. They actually had limits for their users. You can have 100 gigabytes. That's the limit. If you go beyond 100 gigabytes, they'll cut you off. And you can run 100 queries per minute per user team or whatever, which is probably fine for most environments. But again, this was not just big data. This was humongous data. 100 gigabytes is nothing for them. So users who can get their job done in that footprint should be working in that level, especially if it's something they need quick answers for. And then as you go down this pyramid, obviously it's more optimized for storage. Storage is also dirt cheap these days, but then the data growth is just mind-boggling. So we are constantly craving for more storage, and you could make an argument that's one of the reasons the Hadoop and big data even is getting so much attention. But still, the point is you need to look at your use cases and business value of things being in these different layers, and which are optimized for different things, and then use Hadoop and HDFS appropriately. So let's look at what are Hadoop's strengths. So Hadoop comes traditionally from obviously a batch analytics environment. As it has gotten popular, people are trying to throw all kinds of use cases at it and want it to solve everything. But even today, I don't think it is far removed from its batch processing roots. The core Hadoop technology itself works really well for that. And of course, everybody is working on new enhancements to it, but we need to give those technologies some time to mature. I still look at Hadoop as really a good, cheap storage for warm or cold data. Some people like warm data to be as the term, or cold data. This is the 100 petabytes I'm talking about, which you can go at any time, query if you want. It's not going to return in a couple of seconds, but you will get an answer maybe 15 minutes later or a couple of hours later, depending on the complexity of the query. It's obviously ideal for unstructured or semi-structured data, especially in the early exploratory data analysis phase where you are just searching for things, reaching for things. You don't know what you're looking for. You are running some models, all that kind of stuff. It's really good. And obviously, any highly parallelizable algorithm on large data sets is what fits it fits right away in Hadoop. Now, what are some of its weaknesses? What are the things that makes the elephant frown or get a little antsy? Basically, it's not ideal tool for real-time or interactive analysis. This is where I think tools like Impala and a lot of Impala's competition like Stinger or even Presto are trying to add value, but still those tools are not mature, and Hadoop is not the ideal platform for it. Also, it doesn't do real well with iterative algorithms. Obviously, data is typically denormalized. Complex joins and complicated SQL constructs don't really belong there, as much as Hive supports quite a few features of SQL. It does not consistently do well with all of them. Also, if you're looking for awesome integration with BI and reporting tools like Tableau or MicroStrategy, a lot of pieces of Hadoop are still not there yet. That's something I forgot to mention in our use case with these analysts and the BI team. Obviously, those integrations were really important too. So anything that was reporting intensive or BI intensive, we are basically also going to move to the MPP environment because that operates well. So now if you look at an MPP database, what are their strengths? It's almost the opposite in some sense. Hadoop's cons or their pros, they do really well with task queries and aggregations. I know some tools like Vertica, some of the aggregations, they just store in their metadata. They don't even touch the data set. In fact, one of their consultants was saying how you could delete the entire table and still get the aggregations because it's stored in the metadata. Obviously, it has mature SQL and join support, and it also has good real-time and streaming semantics, especially Vertica. They do really well with event window functions and time series analysis, and they do a good job with interpolation, native gap filling, some of the time series use cases. So you can almost use it like a streaming engine for some use cases. They also do well with clickstream sessionization, and they have some analytic functions which would do all of that good stuff. So that's at least some of the strengths of the MPPs in general. But what are their weaknesses? Obviously, they ain't cheap, especially if you want to grow it to the levels of 100 petabytes. You are talking massive dollars, so I wouldn't recommend that. Especially, I think a tool like Vertica charges per terabyte or something like that. So that's not going to work in terms of costing. Also, it's not great for unstructured data. So just like Hadoop is good for the early exploratory work, this is not good for that. This needs to come later when you've done enough work on the data, you have a good solid data model, you know what you're doing, you know what your aggregates are, queries are, and then you take it to a tool like MPP database. It really does well. Also, sometimes they are not ideal for ETL type work. They will do it, but it will, if you want to use the environment for what it's intended and what it's good for, then you really need to use it as an analytic tool for those aggregations, for those analytic functions, and just not overload it with a whole bunch of ETL type work, which is probably better off sitting in Hadoop. So the idea is basically goes back to the what we spoke early on. It's about evaluating your business use cases, quantifying the pain points and benefits of solutions. Basically, you need strong understanding of what is the value of each of your use cases and how much are you willing to spend and is it worth it, because everybody wants their job, their query, their function to work really fast and on the best technology. But some of these technologies are expensive. There needs to be a clear understanding in a warehouse environment to decide what belongs where. So this is where you need to do the due diligence. You need experts, whether it's Hadoop experts or the MPP experts. You need to get people in the room talking, understanding, and essentially picking the right tool for the right job. And be open to owning a diverse tool chest. We walked into this environment where all they had was, Hadoop was their hammer, and that's the only tool they had, and they were going to do everything with Hadoop. So obviously that was not going to work. So we need to expand the tool chest. But the idea is not to just build this massive variety of tools, which just then it becomes a pain in and of itself, because there is so many tools, you need so many experts, data needs to move all over the place. That's not ideal either. What's ideal is having a really organized set of tools, understanding what tool is best for what, moving the ideal use cases to those environments, and guiding your warehouse users in pushing them in the right direction. Obviously, in this environment, we spoke a little bit about the MPP databases and Hadoop, and actually Hbase plays a big role as well. That's part of the tool chest. And Hbase, again, is one of those tools I've seen at many customers, tends to be misused a lot. So people almost look at it like a relational database, which it's not. They look at it almost like a transactional application tool, which it's not. Hbase works well for what it does, which is basically it is well suited for sparse data sets with variable schema where each row can be slightly different. It is good for key-based access. It's definitely not a replacement for your relational database. Of course, it doesn't support SQL. It doesn't have an optimizer. It doesn't do joins. So it goes back to understanding these tools and doing the right things with it. And the other part of it is just understanding where Hadoop is and where Hadoop is going. I like to call this Hadoop plus plus. Basically, what we are seeing is obviously there's this whole drive towards real-time query and more interactive analysis of the data on Hadoop and more responsive interaction with Hadoop. This is where tools like Impala, Stinger, Drill, Presto, they are really spending a lot of their energy on. Closely tied to that is people are trying to replace the complete layer of MapReduce and do something more efficient. Yarn is, of course, part of that. Facebook has an open sourced tool called Corona, which kind of does the same thing. And in a lot of these complex warehouse environments, you also need a good workflow management. Some people like Uzi, some people think it's too complicated. Maybe you need something simpler. In our environment, they did not use Uzi, but they had their own homegrown pipeline management tools. That's something where I think there's some work needs to be done as Hadoop is evolving. Of course, multi-tenancy, where how do you handle mixed workloads? How do you give SLA predictability to higher value users, and kind of maybe should you support preemption and things like that? And closely tied to that is namespace management. How do you handle data from different groups? How do you share data between different groups? All of that stuff. Plus, Hadoop can use a lot of help with metadata management as well. H catalog is something that's happening. Basically, Cloudera has some tools like Navigator, which is part of their enterprise product, I think. I don't know a whole lot about it, but it does a little bit of audit trails, and it's going to do lineage in the future and things like that. So essentially, the elephant is growing and maturing, and we need to have a very clear understanding and grow with it to make the best use of the platform. That's why if we come into your enterprise for any kind of recommendation, think big. Typically, we walk in with this reference architecture. As you can see, this has like a layout of all of the things that an enterprise might need. The environment this case study spoke about does not even touch all of these pieces, but definitely if you go through this, you will see there is a place for all of these different technologies, and there's just various options, and we need to mix and match and leverage data in the best way we can. So there is a place for slower running batch-oriented analysis. There's a place for more real-time fast queries. It's basically an ecosystem of components. We cannot just look at Hadoop or any other database in this day and age and say, okay, this is my tool, this is my solution for all the problems. So that I would probably think is the one single takeaway from this talk. So that's all I had. Hope it was useful. Feel free to ask me any questions now, or there's an email there where feel free to reach me. Of course, you can always go to our website for these kind of resources. We have a lot of good stuff in there, and hope you guys have a good rest of the week and a great weekend.
Thanks, Aravind. This webinar will be ready for replay on our website later today. Thanks for joining.